Hi, welcome to the next lecture. In this lecture, we're going to talk about a FIFO. What is a FIFO and why do we need it? Okay, so first, let's just talk about what a FIFO is. So a FIFO is actually like a block memory, okay, that can contain all of our data. And inside the VIVADO, we have the option to implement an IP for a FIFO. Now, what does it mean that we can implement the data, and why do we call it a FIFO and not a block memory? Now, all of the FIFOs doesn't come with an address, okay? So as it comes from its name, FIFO means first in, first out, okay? First in, first out. Okay, so we can think of a FIFO like a shift register, like a long shift register. And what does it mean is that the data that I'm writing, okay, so let's just say that I have a data in, okay, and I'm writing it. And right here we will have many cells, okay. And so the first data to go out when I'm reading will be the first one that I put inside my shift register. Okay, so this is how you think of you can think of this FIFO. But actually in real life, so our FIFO is actually like a can. Okay, so let's just say that this is cell number 0. Okay. And let's just say that I have 1024 of them, okay? And this is the last one. Okay, so I have many cells, and when I'm putting a data in, okay, let's just say that this is the first data. I'll call it data 1, okay? And after this data, I'm just going to write the next data. Okay, so right here, data 1 will sit, and right here data 2 will be, okay. And when I'm going to write the first one to go out on reading will be, of course, data 1 and then data 2. Okay, so actually we can save data to it, but we always need to remember that it doesn't have any address, okay? So we don't actually, and you will see it in the VIVADO. So we only have data, okay? It can be, parallel data, okay? We can do only 1 bit data, okay? And then it will be, it will looks like more like, this, okay, register if you have 1 bit of data. And we will have write enable, okay, so we can write, and right here we will have read enable, okay. And of course every FIFO will tell us if it's full, okay. So I will not write any more data, because when it's full, what happens is that you will start deleting your own data, okay. And it's not good to write to a full FIFO, okay. It's making many problems. And for reading, you need to know if it's empty, okay. So it always telling you, it's always good to use this signal of for reading. So another thing that is not so good is to read an empty FIFO, okay. So you have your these two signals, the empty and the full, which are like flag signals, okay. And you have the read enable, the write enable, data in and data out. Okay. Now, next thing I want to talk with you about, so why do we need a FIFO? So beside saving all of this data, we have another thing with the FIFO. We have a clock to every FIFO, okay? Now, one uses so first of all, we can use FIFO with one clock, okay? So let's just say that I have here the clock in, okay? And I'm putting some clock, let's say that I'm putting 100 megahertz, okay? And this is, let's just say that this is what I want. So I will have to write the data actually in 100 megahertz, okay? And I will also read the data in 100 megahertz, okay? So this would be my clock, okay, for the data, okay? So this clock will be actually the frequency of all of this communication between the two sides. So it means that if I have something right here, it will have to work on 100 megahertz, okay? And if there is someone here, okay, some process here, it will have to work also in 100 megahertz. So actually this is just saving data, okay? It's just saving data and making it, so it's just saving it, and when this process here is ready, it will just pull the data out, okay? And when the FIFO is empty, I can put more data. So this is just saving data, as it already have been said, okay? And now there is another thing that you can do with FIFO, and this is actually more important, okay? And this is actually something that I love using it. So let's just say that you have a signal, okay? And let's just say that you have a signal that coming from fast clock, okay? Let's just say that you have a signal that coming from fast clock, and right here you have data, okay? You have data in, and you have right here fast clock, let's just say 100 megahertz, okay, once again. And another thing that you can do with FIFOs, you can separate the frequencies, okay? So the clock input and the clock output will be different, okay? So this is the clock in, okay, of the data in, right? When I'm saying in, it's the data in, and this one is also a clock. It's an input, but it's for the data out, so we will call it clock out, okay? So this is an input of a clock, but it's for the data out, okay? And let's write here data out, and let us say that right here I have 50 megahertz, okay? Now let's just say that I wanted to move data from one process, okay, that come in 100 megahertz to another one that it's a little bit more slow, okay? And let's just say that the data is not coming every clock, but when it's coming, it's on 100 megahertz. And I have I have an amount of data that, let's just say that I took, a big FIFO, and let's just say that I can, use this FIFO in order to, just save the data inside the FIFO, okay? Now the thing is that I want to move the data from one clock to another, and doing that, it's actually quite a problem, because the data is coming from a fast clock to a slow process here. So if I'm sending too much data, I need to to control it. I need to tell this process to stop, and I want to actually have the the opportunity to stop it, okay, and tell him don't send me more data. So I can use a FIFO. So this is one thing that it's doing, okay? So you have here the signal that's saying, hey, I'm full, okay, don't send me more data, because this slow process did not make it in time to just empty the FIFO yet, okay? And this is one thing that you can that helps with the FIFO, okay? to the whole design of the system here. And another thing that happens here is that you don't have to deal with synchronization between the 100 megahertz to the 50 megahertz. Okay, so you don't have to deal. These two clocks doesn't really need to have to be even synchronized to each other. Okay, so let's just say that you have 100 megahertz that going like this. Okay, and the 50 megahertz, I'm not saying that it's, let's just say that everything is working in a rising edge. So I never said that the 50 megahertz come in right here. Okay, this is not the thing. Maybe the 50 megahertz can be right here. Okay, I don't know. And the rising edge of this one, of the 100, and the rising edge of the 50 megahertz can be actually in a different place. Okay, and if we are going to use this FIFO between them, we don't have to synchronize anything. Okay, we don't have to do actually anything right here, and this is a good thing. It's solving many problems. Another problem that by the way, okay, so this is for moving from fast clock to a slow clock. What happens on the other side? Okay, if this one will be the 50 and this one will be the 100, you don't even have to look on the full anymore, and you don't have to look on the empty. I mean, it's good to look on them because this process might, fail. But if you have a process that always taking the data out, and you know that this one is 100 megahertz, and you have a process here that's sending or not sending even the data in, but it's on 50 megahertz. So even if this sending always the data, but you know that this one will always pull the data in every clock, then you are actually covered here. Okay, so you don't even need to take care about this signal anymore, but you will still have to look on the empty one. Okay, so if we are moving from a slow clock to a fast clock, we are even in a better world for us. Okay, and still so moving from a slow clock to a fast clock, sometimes it's less likely to use this, because you can say that the fast clock always covering if you're sampling twice the slow clock, the data from the slow clock, okay, you're covered, but you can do something else with this. Okay, so if you know that this one always, pulling out the data, and this one always putting the data. So we can do something else when we are moving from a slow clock to a fast clock. Okay, we can actually use let's just say that our data is 32 bits. Okay, so we can just use one single cell, okay, of 32 bit. Okay, so let's just say that this is 32 bit. Okay, so our depth of the FIFO will not be, as I said before, from a 0 to 124. We just use this one. Okay, so we can just use okay, the thing that we just say on the first when we started the lecture. Okay, so this can be, okay, just just a register that moving the data, okay, from the slow clock to the fast clock. So it all depends on how you build your architecture. Okay, so it all depends on what you need in your project. Okay, so every project can be different, and this is it for this lecture. And just remember that you have many options to do with the FIFO, and it can help you a lot with your design. Okay, so you won't get into troubles of synchronizations and and jitters and everything that we don't like, okay, the designers. So I will see you on the next lecture, and this is it for now, and thank you.